So part C, again, asks us to evaluate f prime of a for an f of x that is equal to the square root of x plus 1, and a is equal to 0. So let's first find f prime of a for the function square root of x plus 1. And then once we have f prime of a, we can plug in 0 for value of a. So again, our definition of the derivative at point A, f of a plus h for my given function here would be the square root of a plus h plus 1 minus f of a, f evaluated at point A, which would simply be a plus 1. And all of this is divided by h. In evaluating a limit, we saw in the previous chapter, whenever you have an expression that involves a difference of radicals or a sum of radicals, the first strategy we take is to multiply those expressions by their conjugate pairs. So the conjugate pair of the numerator here would simply be the square root of a plus h plus 1 minus the square root of a plus 1. And of course, if we multiply this expression by this number, in order to keep an equivalent expression, we need to divide it by itself, so that effectively we're just multiplying our original expression by 1, which won't change anything. All it does is it'll change the way it looks, so that it'll help us evaluate the limit. Okay, so a plus 1, conjugate pairs, and I'm sorry, the conjugate pair should have been a plus there, right? Okay. So let's evaluate, or let's do some algebra here. So multiplying an expression by its conjugate pair will give us a plus h plus 1, put that in brackets, minus a plus 1 divided by h times all of the conjugate pair. Okay. So a whole bunch of things are going to start canceling out here. Okay. A minus a, 1 minus 1. The numerator we're left with just h alone, and h will divide by the h in the denominator. So the expression that we're left with should be simply, let me change colors here, back to black. So it should be the limit as h approaches 0 of 1 over a plus h plus 1 plus the square root of a plus 1. And now we can evaluate the limit, plug in h is equal to 0 into our expression, and this limit ends up being 1 divided by 2 times the square root of a plus 1. We're now ready to evaluate f prime of a, where a is equal to 0. Plug 0 into f prime of a, and we get 1 over 2 times the square root of 1, which is simply 1 over 2.